Today we are going to start with a chapter called solutions. This is very important for your exam. This chapter contains 12 marks for your final exam. You will get 2 numerical problems. Each question carries 3 marks and short answer type questions. 3 questions, each question carries 1 mark, and MCQs, each question carries 1 mark, total 3 marks. So 3 into 2, 6 plus 3, 9 plus 3, 12. Total weightage of the marks is 12 marks. So this is your first chapter in second PUC. We are starting with the definition of solutions. So what comes to your mind if I say solution? So every day we are using different types of solutions in our day-to-day life. So how can we define that? So solutions are homogeneous mixtures of 2 or more than 2 components having composition and properties uniform throughout the mixture. So what is this mixture called? In every day we use tea, coffee, soft drinks, and even the air what we breathe. Everything is made up of mixtures. Nothing is pure components. So what is this mixtures? What comes to your mind if I say pure substances? All these terminologies we have studied in first PUC. So let us go back to that part. In the first PU we have studied this particular topic called matter. So matter is divided into 2, pure substances and mixtures. So in our daily life we are using many substances, we are using many solutions which are all mixtures. Those are all not pure substances. So mixtures are further classified into 2. One is homogeneous mixtures, the other one is heterogeneous mixture. Homo, as the word itself it indicates same. Hetero means different. So again heterogeneous mixtures are further divided into 2. One is colloids, the other one is suspension. So not only homogeneous mixtures, in our day-to-day life we see many examples for heterogeneous mixtures as well. So in this particular chapter we are concentrating more on homogeneous mixture. So why? Because we are concentrating on solutions. Solutions we are mainly studying under homogeneous mixtures. So what solutions definition we have studied. Whatever the generally we have a tendency, if I say solution, what comes to our mind? Solution means liquid. But that is not the case. Solution, it can be in a solid state, it can be in a liquid state, or it can be even in a gaseous state. Example, we all are aware of gold, right? Gold is a solution. But what we think gold is a solid. Yes, it is a solid, but it is a solid solution. Why we are calling it as solution? Because solution has 2 important components. One is solute and the other one is solvent. Even if you take an example of gold, gold has more than 2 components in it. But it is not possible for us to differentiate because majority of the part is gold and some minor amount of nickel, copper and many other alloys will be present here in the gold. So, but we cannot segregate that. So, this is an example for solid solution. Similarly, liquid solution we all know. Gaseous solution, air what we are breathing, that is a best example for gaseous solution. Next, we are moving on to the important components of solution. As I told you, solution has 2 important components. One is solute and the solvent. So, how can you define the term called solute? Solute means amount of substance. When I say amount of substance, I am concentrating in terms of moles. If I say amount I am telling in terms of moles present in less quantity. Amount of substance present in less quantity, that we call it as solute. Solvent means amount of substance that is present in more quantity. The 2 in terms of moles. That is nothing but our solvent. So solution has two components, one is solute and solvent, and mainly we are dealing with binary solutions. Binary means only two components, one is solute, the other one is solvent. It has only two components in it. So now we understood the meaning of solute and solvent which is present in our solution. So with this knowledge we will try to take up one problem. So now 36 grams of water is mixed with 6 grams of hydrogen gas. So in this I wanted to know which one is my solute and which one is my solvent. Just by looking at the problem and the definition what we learned, what comes to our mind? The one which is present in lesser quantity we consider it as solute, and the one which is present more quantity that we consider it as solvent. But let us understand that practically. So mole, we are defining the definition of solute and solvent or amount of substance in terms of moles. So mole means what? Mass by molar mass. So what is the mass that they have given? 36 grams of water. So let us write that as it is 36 grams divided by molar mass. How to calculate the molar mass of water? So this is a calculation for molar mass of water. So H2O, mass of hydrogen is 1, mass of oxygen is 16. So 1 plus 1 plus 16, total 18 grams per mole. So let us substitute this 18 grams here, so that if I divide 36 by 18, I will get 2 moles. So now similarly we have to calculate the same thing for hydrogen. So same, first write down the formula, mole is equal to mass by molar mass. What is the given mass? 6 grams. Molar mass of hydrogen we need to calculate. We know the mass of hydrogen is 1. So 2 moles of hydrogen, so 1 plus 1, 2 grams per mole. So now let us subtract this value here, molar mass. So 6 by 2 is 3 moles. Now you can observe, here we got 2 moles, here we are getting 3 moles. So now we should decide which one is solute, which one is solvent, not just by looking at this grams. So now this is 2 moles, this is 3 moles. So the number of moles here is 2, which is less than that. So this we are calling it as solute, and here this is solvent. So this is how we understand the proper definition of moles or solute and solvent, how to identify solute and solvent. Now we are going to understand the types of solution. So solution can be in a gaseous state, or it can be in a liquid state, or it can be in a solid state, solid solutions. So now we will understand all different types with the examples. Gaseous solution, in this gaseous solutions you can see 3 different types, that is solute can be gas, solvent can be gas, or solute can be liquid, solvent gas, solute can be solid, or solvent is gas. Physical state is represented by the solvent state. If this is in gas, gaseous solvent. You can see in the liquid solution, the physical state of this is represented by the nature of the solvent. Here it is liquid, so liquid solution. Similarly, in case of solid, solvent nature is solid, so we call it as solid solutions. So here example for gaseous solution, that is solute and solvent, both are gases. Example, mixture of oxygen and nitrogen gases. Oxygen is a gas, nitrogen is also a gas. Oxygen is my solute, nitrogen is my solvent. So this is an example for gaseous solution. Again, if my solute is liquid and if my solvent is gas, here chloroform mixed with nitrogen gas. Nitrogen gas, whatever I am taking in all these 3 cases are the solvents. Here chloroform is solute. Chloroform is liquid, nitrogen is gas. So this is an example for this type of solution. Again, solid in gas, camphor. Camphor is in solid state. When you take camphor is my solute here. Camphor in nitrogen gas. Nitrogen gas is my solvent, camphor is my solute. This is an example for solid gas solution. Again, under liquid solutions, again you have 3 categories. Solute can be gas, liquid or solid state, but I am not changing the solvent state. It is in the liquid state only. So now if you take up the example for first one, here oxygen dissolved in water. Oxygen is my solute, water is my solvent. So liquid solute, liquid solvent. Ethanol is my liquid, water is my liquid solvent. Similarly, solid in liquid. So glucose is present in solid state. When you dissolve that in water, that is an example for this category. Similarly, when you take the solid solutions, these are very, very important for your boards. One question definitely they will ask you from this. So this question especially they have asked in the previous year question paper. So here my solute is gas, solvent is solid. So solution of hydrogen in palladium. Palladium is solid, gas here I am taking as hydrogen. Similarly, liquid in solid. Liquid means what? Amalgam. Amalgam of mercury. Mercury is a only metal which is present in liquid state at room temperature. This is something we all know. So liquid with sodium. So this mercury liquid metal I am taking with sodium. Sodium is my solvent. Mercury is my solute. Similarly, the last combination solid. Here my solute is solid and solvent is also solid. So copper is my solid solute which is dissolved in gold. I told you gold is also a solution. So gold is an example for solid solution because I have solute also in solid state, solvent is also in solid state. Because we are not using 100% pure gold. You can see some impurities like copper, zinc will be present in gold.